Hello, I'm doing a LeetCode stream. It's a easy count square sum triples. A square triple ABC is a triple where A, B, and C are integers, and A squared plus B squared equals C squared. Given an integer n, return the number of square triples such that 1 is less than or equal to A, B, C less than or equal to n. Hmm. So between 1 and n's range is from 1 to 250 inclusive, because it has the equals too. And that's all there is. You get an n, but that's the range. So I would about say to just do the whole set, but I think, you might as well just do a while loop. And so, okay, right here, example 1. So you can have the numbers switched around too. So that makes it a little more tricky. Looks like there's 2 versions of each one. And then the final number would have to be right, because it's the one that the other 2 equals. So it has to be the same, I guess, is the thinking here. Okay, it's the C. The big one has to be the C because the other 2 squared added together equals the C squared. So there's going to be 2 versions. If you find one, then increment by 2 is what I'm taking from these examples. So we'll write like a while loop and put an N in here. While something less than N. I guess we'll just use A, B, and C, you know, use the things it's given. So we'll say while C less than or equal to N, and we're going to have to make some variables. We'll make variable A, B, and C. Int A equals 1. Int B equals 2, let's say. And yeah, I don't know if that's a good idea or not. I guess I should make it 1 because it. And C equals I guess 1. I mean, let's see, what's it saying here? Because when 1 squared plus, oh no, 1 squared plus 1 squared is 2. So that doesn't equal C squared, which would be 1. All right. So what? Where is your first one? Um, I don't really see a way to do that. Wonder if 3, 4, and 5 are the first. Yeah, I guess so. 3, 4, and 5 is the first one. So you might as well just start like that. 3, 4, and 5 is your first square triple. So you might as well just start there. And if I guess we need a count too. Int count to count the number of triples. We'll just start it out at 2. Then that forces me to put a ternary here. So I'll go ahead and do that. Return if n is greater than or equal to 5. If n is greater than or equal to 5, then return count. Otherwise, return 0. Because it has to be greater than or equal to 5 to have a single triple. So let's go ahead and start incrementing because we already got the first one kind of coded in, hard coded in there. Let's do it in order, you know. There's probably a better way to do this too. Wouldn't surprise me. Okay, if dang, I feel like I need a triple loop here. I mean, there's probably not very many. So what I really need is an efficient way to find out up to n how many there are. What's this other one say? 6, 8, 10 is the next one. Yeah, I'm gonna need a triple for loop or something here. Otherwise, it'll just increment them, and I would never hit the 6, 8, 10. Okay, so oh gosh, a triple for loop. For each int a. So yeah, we're gonna get rid of this. This is no good. Int a equals 3. We're starting at 3. Yeah, we'll start at 6. We'll just code it, hard code it to the next one to count it and get it rolling. Maybe. Still might be too slow being a triple for loop, but since it's a small range, it might not be. It might be okay. A less than equal to C. Let's see. A plus plus. This might be the way to do it. Okay. Now I just want to do that again. But maybe it should be for B. We'll just copy and paste that up. But yeah, let's just make it like to the next letter. Okay, the next triple is 8 and 10. Oh gosh. Oh, went a little crazy on the delete. 8, and we'll make that ABC. Yeah, C would be what I'd want there, but this needs to be changed to B. That needs to be B. And then this one would be C. Okay, C. It's going to be 10 here for the next one. We're just hard coding in the first two, basically. The first two triples. Then C needs to be less than or equal to 250 because there's not another variable above that. And then, okay, still not really sure how good this is. Probably gonna need AI's help to get me a better solution anyway. So if A I mean, can I write A squared? Let's see. I think that's a math. I don't know. I don't think you can. Let's see if you can though. A squared plus B squared. I don't think this is the right way to do it. I think what I'll do is I'll just put A times A and B times B. But let's see. Need to increment it twice. So I'm just going to put like plus equals 2. Where did my tertiary go? Oh, there it is. Okay. Ternary. There we go. Okay, so now there's a lot of brackets. So I'm going to double check that the brackets are lining up. Looks good. Alright, let's see if this works at all. Oh, right. I wasn't supposed to declare these up there because I went to a for loop situation, so they get declared down here, I guess. But I don't think it's going to like this a squared b squared thing either. Yeah, bad operand types. Okay, I'm going to go ahead and fix that right now too, since it already aired that. So we'll just do a times a rather than trying to do like math dot square it or something. We'll do it a little simpler. There probably is a way to, I'm pretty sure there is. Probably math dot square SQR or something. SQ, I don't know. Something like that probably. And that's what we'll put a parenthesis on that too, even though I don't think you need to. Okay, let's see if this works. No. Okay, C. Oh, right. Okay. Because now C's declared down in here, so. Well, I guess you don't need the while loop now. Maybe. Yeah, get rid of the while loop, and then instead of 250, make it end. Yeah, we'll do that. Okay. Okay, so now we're going to be, I need to get rid of the bottom bracket because we've got rid of the while. Got one too many down here now. Okay. Now I'll double check it matches up. Yeah. Okay, now let's see if this works at all. No. No, it does not. Okay, what's the problem now? All right. Because B's down here. Well, I guess we could just put in for all of them. See what we end up with. Okay. Although I feel like that end situation could be a problem. Nah, it's not a problem. It'd do maybe a few more calculations than you need or something, but it shouldn't give you the wrong answer probably. Okay, well anyway, this worked for both test cases, but both of the test cases are sort of hard-coded in, so I'm not 100% confident it'll definitely work for all of them, but let's see. And then I'm going to give it to AI to see if there is some better solution anyway. So yeah, that didn't quite work. Let's see, output 12. Should have been 10 for n equals 18. Wonder what happened there. So, alright. Well, alright. I have an idea. I think due to the in in here, it is counting those twice maybe. Nah, it doesn't really make sense, but let's try it anyway and see what it comes up with. I don't think so though. Yeah, see. Okay. So yeah, I don't know. I'm gonna find out the better solution with AI's help at this point. check with Claude. I'll go ahead and put this code in here. I'm also going to go ahead and put it in my notes. Although I should put it down here because this code doesn't work. It has things wrong with it. Okay. So yeah, this will be interesting to see what is the correct way to do this. I suspect it'll just go through it, the whole range of them, and find out how many there are up to n, and then yeah, I don't know what it's going to do. All right. Yes, it's code. This Java code solves the two examples, but fails test case. Says please fix this solution or give me better solution. We'll try that. And then I'll put the question down there. Okay. I'll fix it up a little. Okay, let's put it in here and see what that comes up with. But I'll go back over here and take another look at this. So it was too short on that one test case. I wonder why that would be. I mean, what about situations where A and B are equal? That's what's happened. It ended up not counting, being able to count those probably. So let's try to fix this code with like doing this. Maybe starting them off equal get us somewhere. Now it's getting the wrong answer for this. Okay. So yeah, I don't know what to think about that. What if I just start them off at 0? What happens now? gets them all wrong. That makes sense. 28, 52. Counting way too much for that situation. Hmm. Alright, let's see what it's got. Looking at your code, I can see several issues. Hard-coded starting values. Yeah. This is valid triples. Hard-coded count, starting with count equals 2. Assume certain triples exist. Triple iteration. Yeah, I had I just thought about that. Like, yeah, what if A and B are the same? Then you should only count 1 instead of 2 for those. Triple iteration. You're iterating all 3 variables independently, which is inefficient and incorrect. So, oh, there's that math square root thing. So it's math.sqrt is how you do that. The key insight is iterate through all pairs AB, calculate C squared equals A squared plus B squared, then check if C is a perfect square that's less than or equal to N. Okay. How it works. For each pair AB, we calculate what C would need to be. Okay. And if it's less than N, then you can count it. We take integer square root and verify its exact C squared equals calculated value. We also verify C is less than or equal to N. Okay. Yeah, it's a smarter way to go about it for sure. I knew I was probably in trouble when I started trying to do a triple for loop. Okay, yeah, you need a double for loop for A and B, and then you just check if those two squared added to each other um, is less than N, and then you count. Okay. Yeah, this is a really good solution. Way smarter. Okay, let's check this out. Let me put that in my notes up here, though. It's a good solution. Okay. Let's make sure it works. I'm thinking it's definitely gonna work. I feel pretty good. Yeah. Okay. So let's look this over. Okay, so you start A and B at 1 and less than or equal to N, and then you increment it in a double for loop type way here. And then you have int squared equals A times A plus B times B. And then int C equals int, oh wait, this is square root, not squared. Math dot square root. So you're checking if it can be square rooted, this C squared situation. Because if it can't be square rooted, then you don't have a c times c. It's not a c squared if it can't be square rooted. That total is what's going on here. And then you check if c times c equals c squared and c less than or equal to n. Count plus plus. Huh. Check if c is perfect square and within bounds. Why would you need to do this then? To get to c, I guess, yeah. That. Okay. Because if it's not a perfect square, then this won't match up. But yeah. Alright. Well, I guess that's it for tonight. And yeah, a little tricky. Like this part's a little tricky. Seems like there could almost be a better way to do that part, but I don't know. That's pretty good. I might hill dive stream tonight. I'm not sure. It's very cold.